Hello guys, welcome to our YouTube channel Scholar Tech Studio. Let's start another lecture on EDEM software. Okay, let's start the creator. Under the creator tree, we have the first option is project. So this will allow us to define the specific name of our project, and also we can write some description about the projects, like what we are going to do in this project. This is not necessary, but you can add some information related to your project, and here you can specify the name of your project, like say simulation of any part, so you can give any specific name. Okay, so after assigning the name, the next option is defining the bulk material, and this bulk material allow us to add bulk material and bulk material particle shape and model, and define the interaction between the particle of the bulk material. Okay, let's start. We right click on it. So the first option is material wizard. So these are predefined materials in the library of EDEM software, but we will discuss later about this one. We are going to add a new material. So the second option is add a bulk material. So what we will do, we will click on it. Okay, so now the material is in the interface. The first thing we need to rename this material. Let's suppose we can say I want to make the soil, so I can put it soil material. Okay, so we have successfully create our material. Now we need to define the material. So when we create the material, so under this tab you can see that we have to define the material. So we have to provide the mechanical properties of the specific material. Here we have to provide the Poisson ratio, and then we have to provide the density of that material, and then we have to provide either shear modulus or either Young's modulus. So we have to provide these values. By default it took some values, but you can put the specific value of your bulk material. Let's suppose I want to create the soil, so I can find the material properties of the soil or from the internet, or I can do some experiment to calculate these properties, and then I can add these properties here. So we only require three things. First is Poisson ratio, the second is solid density, and then shear modulus or Young modulus. Okay, so the next step is the interaction is basically when these bulk material particle will collide each other, when how they behave. So we have to define their collision. So for that, here you can see that there is a plus sign. If I click on it, so now we can see that the list of the material is here, and if you will click in arrow, so you can see that there is only one material, because we only define one material, so only one material is available. Then I said okay. After that you can see that there are three different parameters that we need to assign. The first one is coefficient of restitution, so we have to provide the value of coefficient of restitution, and then coefficient of static friction, and then coefficient of rolling friction. This is basically the physics behind when two or different particles of the materials will collide with each other. Then we require to these values to explain the physics behind their contact, so for their interaction. So we have to provide these three values. So the first step is completed. We create a new material, we define its physical or mechanical properties, and then we define the interaction between the particles. Similarly, if you want to create another material, you are going to deal with different materials in your model. So similarly, we will go to material, bulk material, and then we will go to add material. And this time, let's suppose I type the name sand material. Okay, so similarly we have to This is sand material. Similarly, we have to specify its density, its Poisson ratio 0.3, or its density and its Young modulus. And similarly, now here we can see that there is a plus sign, so we have to create the interaction of particle of the sand. And here we can see that this is, now we have two materials. Okay, so this time I want to select sand and said okay, and here we can specify different these parameters. Okay, so now we can successfully create two materials. Okay, soil material and sand materials. And if I right click here, then here you can see that there is the option of transfer material. This will basically help us to, let's suppose we define a material and we want to use this material in other simulation or in other projects, then we can transfer this material. Okay, we can transfer this material and we can save this material, and next time when we will open that model, so we can just import this material that we already defined. Because if we are going to deal with the same material in other simulation, so we can save this material so that it will save us our time. And similarly, if you see that, you can see there is option of expand all collapse, so this will expand and collapse if we have a lot of material under this option. Okay, now we move to next step. If we right click on it, so here we can see that we can save material block. So we have just defined a material, we can also save as a block, and we can also rename this. If you want to rename this, so you can use this one, or you can press F2. So rename, under the rename option you can give you can rename this material. Okay, so similarly, if I right click on it, then we can see that we can also copy a material. Like if I will select on it, then it will create the copy of the material, and then I can change the name. So okay, and the next is delete a material. Let's suppose I create a extra material and I don't need this one, so I can just right click on it and then go to delete. Okay, so the next step is we have defined the material and we have defined the physics or interaction between the particle of the material. But now in the next step we need to define the shape, size and composition of the material. Okay, so how can we do that? Let's start. Let's suppose we have a bulk material in term of sand. So first a sand particle have some specific shape and sand particle have specific size, and in the bulk material there are some small size grains and or sand or some large size particles. So we will define that. Okay, so right click here, and here we can see that there are three options. The first one is add particle. So under the add particle we have three options: add multi-sphere, add polyhedral, or add cylindrical shape. Okay, and similarly there is a add shape from the library. So this is the library that have some specific shapes, so we can use all these shapes. And the third option is import. We can also import the particle shape from generated from the CAD software. We will discuss later. So we will first start add particle, and we will select the add particle multi-sphere particle. So we select this one. Now we are in here we can see that these are the particle are basically the unit quantity of bulk material. So we can first rename this particle. Okay, so I rename this particle as a soil, or we can say soil particle. Okay, so here you can see that there is a table. Okay, this table is related to these particles. Okay, so we select multi-sphere particle. So there are three particles. So okay, so now we discuss what we can here. So here you can see that the first one is name. Okay, so this is the name. So there are three spheres, sphere 0, 1 and 2. So these are the names. But here if you will go to view and then go to highlight the sphere, or you can also find this option here. Now if you will click on 0, then it will told us that this is the 0 sphere, or this is the 1 sphere, and this is the name of the next sphere. Okay, so in this way we can specify the which sphere is selected. Okay, so next is the position x, y and z. Okay, so let me explain this one. What is the meaning of this one? Let's suppose we have a let's suppose we have a particle, and particle have a center. Okay, so if we have a coordinate system, okay, so this is y and this is x, and there is a normal to this is z. Okay, so if particle is here, so this is the origin of our coordinate system. So this particle have some values of x, y and z. This is basically present its position, like how much far away from x-axis and how much far away from y-axis and how much far away from the z-axis. So these are the positions. So it means that we can see that sphere 0 is on x-axis and its position is here. On y-axis the position is here, and the sphere 3 is at the, we can say, at the center of x. So it means that it's the reference frame is inside this third one. Okay, so these are the position. If we change the values, let's suppose if we change the value of x, y and z, then this part will move. Okay, similarly if we will change these values, then these particle will move along. Here we can see that the main frame of reference, this basically tell us the direction. Like if we change the direction of x, then it will move from this side, and if we change the direction of y value, then it's move in from that side. And similarly if we change the value of z axis, then it will move on upward direction. So in this way we can do the changes in the shape of our particle. Let's do some changes. Okay, let's suppose this one is 0. Let's put 0.01 and then click here. Now you can see that it's moved to some extent. If we change the value 0.002, okay, so now you can see that it's moved in the x-axis direction. So here we can see that it's moving in x-axis direction. And similarly if you want to move this one, then we can move, and even we can, so in this way you can move. Let's suppose if we want to give some height, we want to modify the shape, and we want to place this at the height of, so then we have to give the value of z-axis 0.001. Now you can see that it's moving on z direction. So in this way you can move, you can change the position of these spheres to get your likely to be similar shape of your particle. And similarly here you can see that this is the radius, so this basically used to increase or decrease the size. So let's suppose if I want to make it 2, then it will be bigger. Now you can see that it's bigger. So these options we can use to modify the position of particles and then to make the shape, and we can also change the size of the particle. Let's suppose if you want to make more particle, like these are 3 particle and want to use 4, 5 or 6 particle, then you just need to right click here, and here you can see that there is the option of add sphere. So add sphere, so this is the sphere, at the original position is 0, but if we will give some position then it will be move. Let's suppose I give the position 0.005. so now you can see that this is our new part. So in this way we can modify the shape of this sphere to give the shape to our particle of material. Okay, so in this way we can use these options. Okay, so here you can also see that this is basically the library, shape library, you can see. So okay, so from the shape library you can see that there is a single sphere, dual sphere, triple sphere or square. So in this way, I just select here, now it's changed. Now I have 4 spheres. Now I can, if I want to modify these, I can modify. So in this way we can give the shape to our particle of the materials. So these are the options are available here. Similarly, if you want to delete, if I right click here, so we can see that we can delete, we can duplicate, and then we can copy and paste any shape of this sphere. And similarly, if you want to make a straight shape, okay, and then this is the center, and which you will increase the size like 2, and also see, now you can see that the picture size is modified. Okay, so in this way I think now you understand how can we use this table to change the size and position of the this sphere to get our specific shape of particle. Okay, so I think this is okay. And if we right click on it and then we go to, okay, so the next option is size distribution. Okay, before the size distribution, let's first discuss the properties. Okay, so now this material is created, and every sphere have some mass and inertia, so we need to calculate these properties. So here we can see that we have 3 options: spheres, user defined, and importer templates. If that will discuss with this one when we import some geometry, but now we will use these spheres and user defined. You can define the properties of these shapes, and you can also, the best way is you just use the auto calculate. Now we can see that the material is assigned, and the different properties like mass, volume, and moment of inertia is assigned or calculated with respect to these geometries. Okay, so the next step is size distribution. Okay, so let's discuss about the size distribution. What is this? Let's suppose we have a container and we have a soil in it. So this is basically a box. Okay, so this is the box and this is our bulk material. So in that box we have soil, and we have defined the first physical properties of that soil. Okay, so these are the soil particle like this. Okay, then we define the shape, like how particle are look like. We just finished. Okay, and the next option is size distribution. So if you will think about the bulk material, then we can say that bulk material, the size of the bulk material is different. Like let's suppose you have a grain, so every grain is not have exactly same size. So maybe some grains are small, some are large, and similarly if we consider the particle of the soil, some particles have smaller size and some particle has larger size. So what is the distribution, like how much particle like are the like the distribution of particle size. Okay, so so for that we have to define the distribution. Let's suppose first one is fix, and so first option is fix. it means that all the particle have the same size. Okay, so then it will create the bulk material, so every bulk particle will be the same size. Let's suppose we have 100 particle. Okay, then all the 100 particle are exactly same size, so we can use fix. Okay, and we can also define by a radius or volume. Let us discuss this option. Okay, so this is our particle. Okay, this is our particle and it has some radius, this is called the r, and also have some volume. Okay, so if we select the radius, then it will make the variation according to the radius. So if we select the radius and here we have ratio 1 and here we select the fix, it means that all the particle have the same radius. Okay, and if we select the volume, then it means that all the particle have the same volume. And if we will change this option, then let's discuss. Okay, so next option is log normal. So here we can see that there is a mean and standard deviation. Okay, and based on radius and based on volume. Okay, so let's suppose we have a sample of soil and we calculated the size of these particles. Okay, and then we apply the statistics on that and we find the mean and the standard deviation, okay, from this sample. Okay, so that will be a single value. This is the reverse process. In this we will define the standard deviation and mean, and then it will create the sample by using these statistical parameters. Okay, and similarly there is another option that is called normal. So this is also a this is also a statistical parameter in that can do the same. We will just provide the value of standard deviation and mean, then it will create the sample of our bulk material. And there is an option is random, and here we can specify the sub maximum size and minimum size. Okay, so let's suppose we have some smaller size and we have a large size. Okay, now we are going to, this is our minimum value, so the minimum size of the particle and the maximum size of the particle. So we will give the upper limit and lower limit, and then it will create the particle between these, randomly create the particle between these ratio. Okay, so in this way we can do select this option. So it depends upon what type of simulation we are going to do or what type of data available for the bulk material. Okay, so the next option is user defined function. So in this we can specify the by like the percentage of different particle size. Let's suppose the scale is 1 and the total percentage must be equal to 100. It means that if the scale is 1 and this is 100, it means that all the particle have the same size. And if I click add, and here we can put the percentage is equal to, let's suppose, 50. Okay, so it means that 50% of these particle in the bulk material have the same size that we just defined. Okay, if I put 0.9 and here I put just 25, so it means that 25% of the particle in our bulk material have the size 0.59. It means that less size from the 1. Okay, so less size from the 1, 25% are smaller. And similarly, and here you can see that the total is still total is 75, but we have to specify must be equal to, the total mass must be equal to 100. So we can add another, sorry, add, so this was 0.9, this is equal to 0.9, and this is 25%, and this one is 1.2 and is equal to 25%. So it means that 25% of the particle in the whole bulk material will be greater size. So in this way we can define the size by using the user defined function. Okay, so there is another option that is called import. By using this option you can also make a table in your Excel or CSV file like scale or mass, and maybe if you have a distribution larger, maybe 10 different distributions or 20 different distribution or 20 different size, then you can create a Excel file and then you can use this as a CSV file and then you can import, then it will create table like this one. So these are the options in the add material, and similarly we can do this for the next material. So in this video we covered almost all the steps and all the available options related to how can we add bulk material and how can we define its physical properties and how can we define its mechanical properties and physical interaction between the particle, and how can we assign the shape, okay, and how can we define the size distribution of these particles in the bulk material. I hope you like my video. Please subscribe my YouTube channel and press the bell icon so that you can get the notification of our upcoming video. In next video we will discuss about the materials, these wizards that are already created in add-ins in EDEM software interface.